Very good morning to all the students. So today we shall have a discussion in continuation with constructional features of CNC machine. So in that we are going to discuss in detail about the mechanical transmission system. So in that, so how the rotary motion is converted into linear motion, that is elements to convert rotary motion to a linear motion, and the second concept is torque transmission elements if the time permits. So basically our topic of discussion in the today's session is in connection with the elements to convert rotary motion to a linear motion in detail with the sketches. So before I proceed with the today's session, we need to understand one important point here, that in the previous session we have discussed in length in connection with the drives. So in that we have discussed in length in connection with the servo motors and stepper motors. So we need to understand one important concept as far as the function of a CNC machine is concerned, that we always require to convert the rotary motion into linear motion of the table. So we know that because these servo or stepper motors are going to provide excellent speed regulation, because the accurate positioning of the table plays a very important role as far as the machining is concerned. So considering that important point, we need to understand how we are going to convert, means what type of mechanisms are used, okay, so that, or what type of elements are used for converting the rotary motion into linear motion of the table. That is very, very important in case of CNC machines. So let us define what is the meaning of a mechanical transmission system first. The function of the transmission system is to translate the rotational power of the motor into linear movement. Just I have told, the main intention is to convert the rotary motion of the servo motors or the stepper motors into linear motion of the table. That is very, very important. Suppose if the generally means as far as the basic construction of the CNC is concerned, the table is going to have X and Y axis. This is a very basic concept. So for X axis one particular servo motor is used, and for Y axis a particular servo motor is used, and both are being synchronized and being controlled by a control unit of a CNC machine or a CNC system. So when this is going to happen, we require to give the moment for the table in X axis, we require to give the moment to the Y axis. So how these axis, okay, linear motion is given. So that is what we are going to discuss. That function is carried out by the mechanical transmission system in case of a CNC machine. To meet these criteria, almost all the CNC equipment will use either rack and pinion or some type of screw and nut mechanism. So we need to understand here, we are not going to design any big mechanism like that. So we need to understand here that how we are going to convert this rotary motion into linear motion, and our basic concentration is on screw and nut mechanism. So if you take a simple screw and nut mechanism, which we are going to use every day almost, because whenever I am going to rotate a screw, there is a movement of the nut. Okay, so we are going to give the rotational movement to the screw, and as I am going to rotate the screw, there is a movement to the nut, either towards the head or away from the head, depending upon how you are going to rotate a screw. This is a very simple concept. The same concept is applicable to the CNC machine also. This is a basic fundamental principle which is adopted in case of a CNC machine to convert the rotary motion into linear motion of the table. Or another mechanism is also commonly used, that is called as a rack and pinion arrangement. So all of you already studied in the mechanics of machines that whenever we want to convert the rotary motion into linear motion, the rack and pinion arrangement can also be used, where we are going to provide the rotary motion to the pinion, which is nothing but a small gear which is connected to a motor which is rotated at a particular speed. So as it rotates, the pinion which is in contact with the rack teeth give the movement in a linear direction. This is how the principle is being used here. So let us understand the components of a mechanical transmission system. Mechanical transmission system consists of the following components. What are the important components we need to understand? The first one is elements to convert the rotary motion to linear motion. Just I have explained about that. So in that, our topic of discussion is recirculating ball screw and nut and rack and pinion system, because these two are the elements which are used for converting rotary motion to linear motion. And the second concept is torque transmission elements, where we are going to discuss, if time permits, that is the gearbox, timing belts and couplings. Otherwise we are going to continue the torque transmission elements in the next session. So as you are going to see clearly on the screen here, so a general concept which I have told to all of you is that this is called as a ball screw and nut mechanism, and we are going to use the word known as a recirculating. So what is a general concept? We require to consider only, if I consider only a screw and nut is also a correct as far as the mechanical movement is concerned. So because in screw and nut, what happens? There is a direct contact between the screw and nut and there will be a frictional loss. So that can be replaced by using the recirculating balls which are provided within the unit, so that it is possible to reduce the friction to almost zero, and then we can have an accurate positioning of the work table. That is what we are going to discuss in length in the subsequent presentation. So before we proceed with the recirculating ball screw nut mechanism and the rack and pinion, we need to understand what is the requirement, means what we expect from that particular element. It should have a high stiffness. This is a very basic requirement as far as the function of the mechanical transmission system is concerned. High natural frequency, okay, this is also very important requirement, and it should have a low friction. That's what I have told now just now. Sufficient damping, it should be able to even absorb the vibrations coming up when the transmission is going to take place, and backlash free operation. So what is this backlash? So I'm going to rotate the screw, but there is no movement of the nut. So such a defect, we call it as backlash free movement should be there for the mechanical transmission system. Then only it is possible to see that the positioning of the work table is going to be carried out correctly. Now we are discussing in length in connection with the recirculating ball screw and nut. This is a very important concept as far as the conversion of rotary motion to linear motion is concerned. So here also it's a very simple mechanism. So where you are going to see clearly here on the screen, here we'll be having this is called as a screw, okay, which is made to rotate, and this is called as a nut, and whatever you are going to see, these are called as the balls which are made to move within the slots provided. You are going to see the slots clearly here. You are going to slots means nothing but a grooves. You are going to see the grooves here which are cut on the peripheral surface of a screw perfectly, where there is an insertion of these balls. These balls are inserted in the space in the grooves, okay, and as this screw rotates, there is a fixed movement of these balls in a particular direction, and again it comes back. So as it takes one complete turn like this, okay, then what happens, it's going to give a movement to the nut either in this direction, means either in a forward direction or a backward direction, depending upon how these the balls are made to move. Basically these balls are called as recirculating balls. There are a fixed number of balls here which are provided within perfectly ground surface within the nut, as well as there is the which are provided within the groove of a screw, which we are going to see there. Let us understand in detail about that. In ball screws, the sliding friction encountered in conventional screws and nuts is replaced by rolling friction in a manner analogous to the replacement of a simple journal bearing by ball bearings. So what we are going to understand here is, in a regular screw and nut mechanism, there is a direct contact. There is a direct contact between the nut and the screw. So if at all in between the nut and the screw, if we provide the balls here, whatever the moment is there, it will be a frictionless moment. So that is the main concept here. The efficiency of the recirculating ball screw is of the order of 90% and is obtained by the balls providing rolling motion between the screw and nut. So here purely it is not a sliding motion, it is called as a rolling motion, because the movement of these balls will give the movement to the nut within the groove of a screw. So that is why it is a frictionless movement for the nut. That is why this nut is in connection with the table or the carriage of a machine. The mounting arrangement of ball screw depends on its required speed, length and size. So whatever the mounting arrangement which is provided, which is used for converting the rotary motion to the linear motion, so that depends upon how much is the speed required and what should be the length and size. So that decides the mounting of the recirculating ball screw and nut. Now let us understand again in detail about that. Ball screw is also called as a ball bearing screw or a recirculating ball screw. We call it as a recirculating ball screw. Again, as you are going to see in detail now about the same concept here. So this is nothing but a carriage which is integrated with this nut, okay, and this portion and this portion, okay, whatever is there, you are going to have a connection here, and this is called as a screw which is made to rotate. And here you are going to see two parts, one is called as A and another one is called as the B. I am describing in detail how the movement is going to take place within the nut and the ball screw mechanism. That is what we are discussing now here. So ball screw is also called as a ball bearing screw or a recirculating ball screw. It consists of a screw spindle. You are going to see this is called as a screw spindle. A nut is there which you are going to see, balls and integrated ball return mechanism. This is called as an integrated ball return mechanism provided within the screw as well as within the nut itself, channel itself. You are going to see that is called as a ball return interior channel, means path for giving the movements to the balls as the rotation of the screw is going to take place. The flanged nut is attached to the moving part of the CNC machine tool. So now you are going to see clearly here the flanged nut. This is called as a flanged nut is attached to the moving part of the CNC machine tool. As the screw rotates, now you are going to give the rotational moment to the screw here. The nut translates, this nut is going to translate the moving part along the guideways. That is how it is going to function. However, since the groove in the ball screw is helical, its steel balls roll along the helical groove and then they may go out of the ball nut unless they are arrested at a certain spot. So that means we require to provide the starting point, which you are going to see that is A, and the end point, so that as it goes from the point A to point B, so whenever it is made to move from point A to point B, it has to return to the point A. So that like that the channel is being provided within the unit. So that is what we are discussing in length here again. Thus it is necessary to change their path after they have reached a certain spot by guiding them one after another back to their starting point, formation of a recirculation path. Okay, the recirculation parts play the role when the screw shaft is rotating. As shown in figure, the screw shaft is made to rotate with the help of a stepper motor, which were not shown there.
okay, and a steel ball at point A. So just observe clearly here. Now there are 2 points here. I'll make it slightly bigger. So you are going to see one is the starting point and another one is called as the end point, which you are going to see. Now the balls which are present at a particular point A, it will, as the screw rotates, okay, these balls will start moving. It will take this turn, it will come here, and finally it comes to this point. So when it comes to this point, these balls are again made to come back to A. So when it is going to, so that means to have a clear-cut information understanding. So now the screw is made to rotate at a certain speed as per the requirement. So as the screw rotates, the balls which are present at the point A will start moving in the groove portion here, because this is made to rotate, and at the same time it is in contact with the nut, and similarly it comes here, and finally it comes to point B. So as it comes to point B, there is an end point, and again it returns back to A. So that path is provided, that is called as a ball return channel, where the balls are made to come again to the starting point. This is how it is going to function. Just I am going to read it out here very clearly. When the screw shaft is rotating, okay, the steel ball at point A travels 3 turns of screw groove, rolling along the grooves of the screw shaft and the ball nut, and eventually reaches the point B. Finally it is going to reach here the point B. Starting point is A and the end point is B. Okay, so now then the ball is forced to change its pathway. You are going to see it is required to change its pathway, and that again it goes to the point A here itself. It has to return to the point A itself. Then the ball is forced to change its pathway at the tip of the tube, passing back through the tube until it finally reaches or returns to point A. Okay, whenever the nut strokes on the screw shaft, the balls repeat the same recirculation inside the return tube. So that is how, that means finally you need to understand here one important concept, that as the balls are made to move from the point A to point B, it will be having almost 3 turns, as you are going to see here clearly on the screen. So this is the first turn, as you are going to see here clearly here, first turn, second turn and third turn. That is why 3 turns will make the balls which are present at point A to come to B, and finally again it comes back here, and the process gets repeated. Okay, and whenever this movement of the balls is going to take place within the grooves of a screw, there is a movement for this linear motion for this part. It is made to move in either directions depending upon how we are going to give the movement to the screw. That is very, very important concept. Now let us have a view of this in a clear-cut view. You can see how it works. As you are going to see, you are going to see the nut which is made to move continuously. The rotation is given to this element which is provided, and you are going to see how the path, you are going to see a red portion ball which is getting repeated and coming back here to the starting point. So this is a continuous process, as you are going to see that it starts from this point and almost it's going to end to this point, and that is why you can say that it is made to move linearly. The rotation of the screw here causes this nut to move with a very frictionless movement. That is very, very important. So that is how it is going to have the function of a recirculating ball screw arrangement, so that it is possible to give the rotary motion into a linear motion, which is very, very important. Now let us understand what are the advantages of using the ball screws. Just we have understood that we require to use the recirculating ball screw and nut mechanism for converting the rotary motion into linear motion of the table. So whenever it is going to happen, why it is used, that we need to understand. Highly efficient and reliable. Because why highly efficient? We are going to reduce the frictionless, we are going to adopt the frictionless movement, and it is reliable. Reliable means what? The accurate positioning of the table can be achieved without any difficulty, and less starting torque. The starting torque is also less because there is no direct contact between the screw and the nut. Otherwise, we require to have a high torque here. Lower coefficient of friction compared to a sliding type screws and run at cooler temperatures. This is very important because of whatever the amount of friction that is generated is very less compared to the direct or a sliding friction. And power transmission efficiency is very high and is of the order of 95% is achievable. 5% slight losses we are considered, but which is not achievable in case of a sliding friction. Could be easily preloaded to eliminate backlash. So we need to understand here, just I have told about the backlash. We are going to rotate the screw, but there is no movement for the nut. Such a defect we generally call it as a backlash. There is no free movement for the nut to achieve. So even that can be avoided by a preloading arrangement. Okay, some amount of load is given so that it is possible to see that the backlash is reduced. The friction force is virtually independent of the travel velocity and the friction at rest is very small. Consequently, the stick slip phenomenon is practically absent, ensuring uniformity of motion. It is just similar to what we have discussed. So what he wanted to tell is there is a total frictionless movement, no stick slip phenomenon, which we have discussed while discussing about the friction guideways. Has longer thread life, hence need to be replaced less frequently. This is also an important thing because the wearing rate is less. Why wearing rate is less? Because the grooves of the screw are provided with the balls or the rollers. Any one of the things is there. Either they are provided with the balls or with the rollers, so that it is whatever the load is there, it is directly coming on the balls or the rollers itself. Okay, ball screws are well suited to high through output, high speed applications or those with continuous or long cycle times. So this we need to understand because we know very well that CNC machines are made to run for 24/7, that is completely continuously. So that means there is a continuous operation of such a mechanism where we are converting the rotary motion into linear motion by the application of the recirculating ball screw. So that is why they are more suited with the desired output can be achieved without any difficulty. Smooth movement over full range of travel. Whatever the movement is there, okay, for the required length of the nut can be achieved very easily. That is also an important this one advantage of using the recirculating ball screw. Aircraft and missiles to move, where they are being used. Let us understand the very important applications. Aircraft and missiles to move control surfaces, especially for electric fly by wire. Okay, basically we are going to use such an application in aircraft and missiles. Automobile power steering to translate rotary motion from an electric motor to axial motion of the steering rack. So whenever we wanted to give the rotary to linear, then we are also going to use in case of an automobile power steering. They are also used in machine tools, robots and precision assembly equipments. So in all this, that means it's having a very wider applications wherever we require to achieve the accurate positioning. So now till now we have discussed about the recirculating ball screws. So we need to understand, just in a recirculating roller screws, the function remains the same. There is no much difference. So these types of screws provide backlash free movement and their efficiency is same as that of ball screw. There is no much difference. So there also we have achieved an efficiency of 95%. Here also it is same. These are capable of providing more accurate position control. Even the planetary recirculating roller screws are going to provide us, because they are, instead of using recirculating ball screws, here we are going to use the rollers in place of the balls being replaced by the rollers. So that is why they can provide more accurate position control. Cost of the roller screws are more compared to ball screws. Definitely the cost of is also increased here The thread form is triangular with an included angle of 90 degrees. And there are two types of roller screws. Actually, in case of roller screws, there are two types. One is called as a planetary and another one we call it as a recirculating roller screws. So let us understand now. In that we are going to discuss basically about the planetary type of roller screws. So before we proceed with the understanding of the planetary type roller screws, we need to understand some of the constructional parts which are provided within the recirculating roller screws. So here you are going to see that the nut is there as usual. Without that there is no question of any movement, which is not at all achievable. So this is called, this portion is called as the nut, and these are called as the rollers. So all these are called as the rollers which are provided, and this is called as a roller gear which are provided at the end of this roller. Okay, and here there is the ring which has to be retained, that is very planetary carrier is there. This is called as a planetary screw because you just see the arrangement of all these roller screws are provided surrounding in a circular path, and all these screws are in contact with the main screw here, which is made to rotate. Okay, that is very important, and you are going to have a spring ring. So let us discuss in length in connection with these things, concepts here. In a planetary roller screw, the rollers are threaded. You are going to see here the rollers are threaded. All these are called as the rollers which are having the threads over its surface. Okay, and gear teeth are cut on each end of the rollers. Try to understand that there is a gear teeth. Just I will make it slightly bigger here. So these are called as the gear teeth. These are called as the gear teeth which are provided at the end of this rollers. Okay, rollers are provided, roller screws are provided with the grooves, and at the end you are going to have a roller gear. Okay, the gear teeth mesh with an internally toothed ring on the nut which drives the roller. That is very important. Okay, to provide a rolling motion between the nut and the screw. There is a rolling motion is there. So why there is a rolling motion here? You are going to see this is made to rotate. Just observe here, this main screw is made to rotate, and along with that these planetary screws will start rotating, and these are in contact with this nut, so that there is with a rolling action, so which can give the movement to the nut here. The gear teeth mesh with an internally toothed ring on the nut which drives the roller to provide a rolling motion between the nut and the screw. Rollers are equally spaced and positioned using spigots which engage themselves in the locating rings at each end of the nut. There is no axial movement of the rollers relative to the nut. There is no axial movement because they are fixed between the two surfaces or the two plates there. They are capable of transmitting high loads at fast speeds. So we need to understand here one important concept, that the first one, the motion is given to this, and around the circumference of this there is a provision of the rollers. So when this rotates, these rollers will also start rotating. When they are going to rotate, along with that they are also made to rotate circumferentially. So as they rotate, they will provide the motion to the nut. This is how the mechanism is going to work out here. Just observe carefully again for few seconds, as you are going to see here. See the movement and how the movement is given for better understanding. You are going to see the rollers there which are placed in a circumferential direction. See, there is a continuous movement of these rollers which are provided here. As you are going to see, circumferential provision is there, and then you will be having the rotational movement of the screw which can provide motion to the nut. Finally it provides the motion to this particular element. Okay, that is very important here, how it is going to function. Okay, just observe such a system where we are going to convert the rotary motion into linear motion of the nut here. So what are the advantages of a planetary roller screw? It is going to give us a backlash free movement. This is already we have discussed in length while discussing about the ball screws. So the main advantage is it is going to provide us a backlash free movement, and it is having a higher efficiency. The efficiency is quite high. Pitch of the screw is smaller than pitch of the ball screw. Okay, faster in operation, very quick, robust it is in construction, capable of high operational speeds, more accurate positional control. So these are some of the major advantages of using the planetary roller screw. That is a part of understanding about the planetary roller screw. So now one more mechanism which is along with your recirculating balls screws or recirculating roller screws, we need to understand here one more important mechanism which almost you have learned, so there is no need of giving a very large discussion in connection with that, because you have already studied this particular mechanism where we are going to convert the rotary motion into linear motion by rack and pinion arrangement. The pinion is also going to have a teeth around its periphery, and these teeth are in contact with the rack, which is of a horizontal type. Okay, so whenever there is a rotation of the pinion is there, with the help of a motor there will be a linear motion which is given to the rack here. And such a mechanism, that is rack and pinion, is always used whenever it is to be required for a longer strokes. That means the longer movement requirement, then there is a preference of the rack and pinion mechanism. A rack and pinion is a type of a linear actuator. It is called as a linear actuator that comprises a pair of gears which convert. So there are actually two gears here. Definitely they are called as a two gears because this is a regular gear and this is called as a linear gear, where you are going to have these grooves which will be in contact with the teeth of the pinion, so that the rotation of this will cause the movement to the rack. A very simple mechanism. The circular pinion engages teeth on a linear gear bar which is called as a rack. So this is called as a rack and this is called as a pinion, and we are interested to give the motion to this pinion, thereby giving the moment to the linear motion in turn to your table or saddle of a machine itself. That is very, very important. Now let us understand what are the advantages of rack and pinion, as we have discussed in case of a roller screws. So what will be the advantages of suitable for longer strokes? Just I have told that such a rack and pinion mechanism is generally used for longer movement of the table. Good stiffness, cheaper, and eliminates the limitations of the ball screw usage, and minimum backlash. Here the backlash becomes minimum. The only one drawback is again for the wearing of the pinion teeth because of the continuous operation. That is there, the backlash is minimum because there is a direct contact between the teeth of the rack as well as a pinion. So that is why there is a backlash is almost zero in case of a rack and pinion. Observe carefully again the parts of this. So in the left side, as you are going to see, this is a pinion which is made to rotate, and thereby giving the movement depending upon the direction of this, the movement of the rack is also going to take place. That is very, very important. Observe for how it is possible to give the rotary motion is converted into linear motion, as you are going to see very clearly on the screen. You are going to have first as the pinion which is made to rotate, and the moment is given in a linear direction. That is how it is going to function here. That is very, very important. Now let us understand where this particular rack and pinion mechanism is being used. Basically conversion of the steering wheels, rotational motion. So in a vehicle, whenever we are going to rotate our steering wheels, it is converted into linear motion of the vehicle's wheels to turn whenever the turning operation is done either to the right or left. Even in such a mechanism, in such a case also, we are going to use the rack and pinion as an application. Rack and pinion systems are a common component in railways also we are going to use, where we require to convert the rotary into linear, and most cars, small trucks and SUVs. SUVs means sport utility vehicles which can carry more number of passengers come equipped with a rack and pinion system. All these are provided with the rack and pinion arrangement for converting rotary motion into linear motion as per the requirement. So in the today's topic of discussion, we need to understand what questions and answers you have to prepare. The first one is list two types of mechanical transmission system that we know. One is a conversion of linear rotary into linear, and next one is the torque transmission elements. And recall the main criterion to be considered in the design of a mechanical transmission system. That is nothing but the requirement of a mechanical transmission system which you are supposed to write. Explain about the elements used to convert the rotary motion to linear motion. So we require to understand. Explain means we have to enlist them, that is the screw and nut, rack and pinion. Then you have to explain in brief about the concepts in connection with the same. I am also going to attach one of the important videos in connection with this. Observe it and also answer the assessment questions. And at the same time, I wanted to inform give the very important information to the students that soon we are going to have a vaccination drive in our college, and already we have the Google form has been filled. I think you've already given up your this one. The students were not yet taken the vaccination drive. Either it will be conducted in this week or by the next week. So you require to come personally to take the vaccination in our college. Let us see. We are going to put the messages in the WhatsApp, and you require to respond very quickly for the same. So with this, I'll be concluding the today's presentation. Okay.
Take a little bit closer look at this. Okay, now this is why it's called recirculating ball. Okay, you've probably heard that it's a recirculating ball steering mechanism or whatever. So without taking this apart, because we could, I just really don't feel like it. You can take this strap off. You can pull these two tubes off. Okay, now these tubes are made in two split pieces because trying to bend that accurate of a radius for those balls to fit in and go in would have been a really hard machining wise, certainly back in the late 60s, early 70s. They could probably do it now, probably much different technology. They don't build these anymore that I know of. It's all rack and pinion. But anyway, this is a ball screw. Okay, CNC machines use the same thing. There is zero play. Okay, there's just a tiny bit of wiggle that way, but linearly, you know, back and forth, there is zero. Okay, and that's why they do it with a ball screw. The other thing too is a ball screw is an Acme screw is the kind you see like all thread. Okay, they've got very hard angles and square shoulders and everything like that. Basically, they hold a ton of torque, and you can put high loads on them and stuff like that. But with this, you would have to spin your steering wheel back to center every time. Okay, with this, you know, you can literally, I don't know if I can do it here at the same time because the whole shaft's, yeah, I can't get the shaft to spin in the tube. But anyway, in your car, yeah, see, there you go. There we go. I'm just doing it wrong. If you turn all the way to one side, the force of the caster on your car wanting to put the wheels back straight will push your sector shaft back to center. And you see just how easy that the ball screw makes the shaft turn. That's why your steering can come back to center. And kind of getting out of the picture there a little bit there. So it's kind of cool how it does that. And it'll do it the other direction. It's just easier for me to do. I'm really not squeezing very hard either. I just can't do it the other direction because it'll just pull right out of the shaft. So, and this block... it looks like it's steel. It looks like it's copper coated, maybe. Not exactly sure why or whatever. But on the other end here, there is the same kind of bearing that was on the front end here. Okay, and if you look, I haven't measured it, but you see that that polished part of the shaft right down there that's after the bearing race? That should be the same diameter as this, okay? That would be the trick, would be to put that piece on this end, you know. If you could cut this off, flip it over so that the screw goes the other direction. Okay, then you could put it on a right-hand drive. If you're converting your vehicle to right-hand drive, you could literally just get another one of these in the housing. The 520 housing is reversible. The 521 is not. But that's a whole other subject. But you need these threads, the ball screw threads, to go the other direction. Okay, for a right-hand drive. This is a left-hand drive. So you could swap the guts out or whatever. In this case, on a 521, you'd have to swap the whole housing and everything, so why take it apart? But anyway, that's a long-winded look at the actual guts, the ball screw that we're dealing with there, and really pretty simple. And I think that's it. Just a quick shot here. See, in the drawing here, you can see the balls, the recirculating balls, okay? Where it comes out over here, you know, because you see the block there, there's the taper of the gear. This is the end of the block right here, and then that's the tubing pieces that stick up out of the end there, okay? And so those balls just make a continuous loop around there, and they're all fairly close together. If you look at the other one, now, the balls on the end here, those aren't actually there. Basically, it runs through the tubing there, and the tubing goes to a couple of the nearer ones, and there's balls down in between, but not all the way out at the edges here. Yeah, you can even see inside the end of the block there that they're in there just a little bit. So those are the recirculating balls. Let's start looking at the